Hello, welcome to this 10th part in the planned 3-part series on object-oriented development for MT4, and I can see that there'll be more parts to come. In this video I will be making a number of references to the earlier video where we built Triple Cross version 2 and even earlier videos in the series where we've been working on object-oriented development. If you haven't seen those, then some of this might be a little confusing, and I've included a link in the description, and there should be one on the screen that you can go back to see the rest of the series. Today I'm taking the EA that we created in the earlier video and extending that by including a trailing stop. I have the template for the new EA on screen, and the changes that we're going to make today: I'm adding a price selection method to the moving average. So previously the moving averages were defaulting to close price. I'm changing the take profit and stop loss methods to be based on the multiple of ATR, and then I'm adding a trailing stop and a trailing take profit, and to do these I'll be creating new classes for trailing stop handling. And then there's just some general housekeeping and common functions, because I intend this to be a general wrap up of this particular EA. To start, I've already taken a copy of the Triple Cross V2 and used it to create Triple Cross V3. The only changes I've made so far are changes to the name, version number, and to add the V3 updates. The rest of the code is identical to version 2. Before we go too much further, I just want to go back over the folder structures that I use. If we look here in the Navigator pane, I've created an Orchard folder under Experts, and under that I've created a Triple Cross folder, and then I have my 3 versions of Triple Cross inside that. I like to create my own folder inside Experts and keep everything in there, because it separates it from anything that MetaQuotes might release. So you can see here they have the sample MACD and the sample moving average EA. This way everything I do is separated. Down to the Includes folder, and I've done the same thing. I've created an Orchard folder which separates it from all of the include files that MetaQuotes release. Inside there I've added more structure. I have a common folder which includes the common base class that we created last time, and the new common functions header file that I'm going to be using today. I have an expert folder where I keep everything related to expert advisors, and this is where I've created the trailing stop folder with the 2 classes for trailing stop that we'll be using today. And from last time I've also moved the filters folder down into the expert, because these filters would be primarily used for expert advisors. As I work through the Triple Cross EA today, I'll be moving to various files, so we'll be jumping around a little bit, but I'll try to keep that to a minimum. Let's start with the common functions. I know that as part of the changes I'm making, I'm going to be adding a trailing stop and a take profit class. If we look back to Triple Cross V2, I have these 2 functions, pip size and pips to price, that we use to convert pip entries into values. I'm going to need those in other places in future, so for Triple Cross V3 I'm simply going to take those out and add them to my common functions file. That way they'll be available to anything that wants to include the common functions header file. And because I've now removed them from here, I'm going to add another include statement in this file. But I also know that these common functions are going to be used in the other classes that I'm creating, and I don't want to add this statement to every one of those classes, but they also inherit from common base. That means that I'm going to be including this common base class file in all of the other classes. So if I just add that include statement once here, then this doesn't actually form part of the inheritance, but because this file gets included when filter base is used, then it will also include this common functions file. So that will be available now to everything that inherits by including this common base file. The next things we're doing are to update the inputs. Firstly, for the pricing method to be used for the moving averages. So let me just change this. All I've done now, I've included an applied price enum of fast MA price, medium MA price, and slow MA price. They were defaulting to the close price earlier. Now there's an option to set those as the inputs to the EA. The other thing I said we would do, I'm replacing the fixed take profit and stop loss pips. I'm replacing those with an ATR multiplier. So I'm taking an input of ATR period and then separate multipliers for stop loss and take profit. So what I'll be doing is calculating the 8 period ATR, for example, and the stop loss will be 2 times that value and the take profit 2 times that value. But because sometimes the ATR can be quite small, I'm also adding this minimum pips for the stop loss and the take profit. So if 2 times ATR is less than 25, then I'll still apply 25 pips. And the only change to the remaining 3 inputs, I'm just going to do a little formatting and change the comment to triple cross V3, and I've updated the magic number so that any trades made by this EA won't conflict with trades made by the V2 EA. By allowing selection of prices in moving average calculations, I'm going to have to update the triple cross filter because previously it didn't accept these as an input. So go to the triple cross filter first, and first thing I'm going to do is to change these variables that I had previously because they don't have a price variable. Let me just put these in. All I've done now is add the fast MA price, medium MA price, and slow MA price. The next change is to the constructors so that these values can be passed in. But I also want to maintain compatibility with the V2 EA, which did not pass these values in. So that means that where previously I had only 2 constructors, I now need to maintain those 2, accepting the same values, but add 2 more constructors that accept the close price value, or that accept the moving average price values. I've labeled each of these methods to make them easy to identify. The first takes the default symbol and the time frame, so you can see there is no argument for symbol and time frame here, and it defaults the applied price simply by calling an init method that doesn't have the applied price. You'll see in a moment that I've created a second init method. So this is the same constructor that was used in the V2 EA. The next takes default symbol and time frame, but in this I have added the applied price. Let me scroll across so you can see those. So the fast MA, medium MA, and slow MA price. And the change here, it's still calling cfilter base with no arguments because there is a default symbol and time frame, but I'm calling a different init method that takes the applied prices. Then another constructor that takes a default applied price but does use the symbol and time frame. This is equivalent to the constructor that we had previously, and that's calling the same init method as above that does not use an applied price, but here the only difference, I'm calling the cfilter based constructor that has symbol and time frame. I'm not using this in the EA because I'm going to be using the defaults where I'm using the symbol and the time frame from the chart, but this is here because you may want to use this with a different symbol and time frame. And finally, everything supplied, I'm passing in symbol and time frame, which means that I'm calling the cfilter based constructor that accepts symbol and time frame, and I'm passing in an applied price, so I'm calling the init method that also has the fast, medium, and slow applied price. So let's go back to the new init method. So here's the original init method. I'm just going to replace that, and now I have 2 methods. This is just the same as the original, where it accepts the fast MA period and method, but there is no applied price for any of the moving averages. And all that init method does is then call the new method. So you can see I'm just returning init, and I'm passing the close price as the default value for each of the 3 new arguments. Then I have the new init method, which I need to scroll across to show you, but it's taking the same arguments, period and method, and then I'm also accepting an applied price. So now we can go down and look at the body of that init method. First, there's a new function definition. I'll paste that in. Need to scroll across again to see that, but it's the same as above. Period, method, and price for each of the 3 moving averages. The next line is the same. That's simply checking to see whether the constructor has failed on the parent class. These checks on the fast MA period being greater than medium and medium greater than slow are the same. This check to see that all the moving average periods are greater than 0 is the same. The only change then is here, where I need to add in the storage of the price for the applied price for each of the moving averages. So all I've added here, the fast MA price, medium MA price, and the slow MA price. And then to the update filter method, where previously I was just using price close, I'm just going to update those to use the member variables. Nothing else changes in these calls. One more change I want to make here, and this is just a housekeeping method or a housekeeping change. Let me show you first by including both here. I was using this formula previously to determine if the bar before bar number 1 didn't meet the criteria of being aligned. And I was doing that deliberately because I've used this in another video. This is a complicated way to write that function, and while it's correct and works, it's a lot more complex and more difficult to read than simply saying that the bar before is not aligned. So you can see that this formula, MA fast moving average greater than medium, medium greater than slow, is the same as the formula that I've used for bar number 1. And all I'm doing here then is saying if bar number 1 is aligned and not bar number 2 is aligned, which is a much simpler way of writing the function than this. So because I've already used that in the other videos now, I'm going to simply change that line. And I'll do the same for the cell function. And those are all the changes for the triple cross filter. The filter base, there have been no changes to that required from any of these. Next thing to do is to create the trailing stop classes. And just like the filter, I'm going to create a trailing stop base and then a trailing stop to be used in this EA. So let's go to the trailing stop base first. I've already got the outline of it here, and just like the filter base, I'm inheriting from common base. Also, just like the filter base, I'm putting the constructors in the protected section because I don't want applications to be creating instances of trailing stop base. Let me put those in. Because this is inheriting from common base, the common base will take care of storing the symbol and the time frame. The only thing that I have that's going to be common across trailing stop classes will be the magic number that I'll be using to identify trades for a particular EA. So the constructor for trailing stop base takes a magic number as the argument. Let me bring this back in so it's easier to see. And then I'm just calling common base with no arguments in this case because there's no symbol or time frame passed in. And then I'm calling the init function with the magic number, which is the only piece of information being added in this class. And then the trailing stop base method that takes symbol, time frame, and magic number. Again, bring that in so it's easier to see. I'm just calling the common base method, passing symbol and time frame, and still just calling init with the magic number. And then my init magic number function. So now let's look at the body of the init. So the init function, the usual check to see if the constructor of the parent class has failed. And apart from that, all I need to do is store the magic number in a magic number variable, which I will create now. And I'm putting this magic number into a protected section so that the classes that inherit from this have access to that magic number. And then I want 4 functions that everything that inherits from trailing stop base should have. So I'm putting those in the public section because they will be available, and I'm making them virtual so that they can be overridden by inheriting classes if needed. First is update trailing stop. It's a natural function. We want to be able to apply the trailing stop update. And I've also got a function called update trailing stop passing in a ticket number because I want to be able to update a trailing stop for a specific trade if needed. Then update common values, and I'm using this because sometimes we want to perform a calculation to determine a value that's going to be used in trailing stops, and we don't want to perform that calculation for every trade that we go through. So I'm creating this one function that can be called once before the EA runs the update trailing stop to set that value so that we can save some of the processor time. And then the apply trailing stop function is actually going to be called by the update trailing stop. So update trailing stop is just going to run a loop, and then it will call apply trailing stop. This makes it easier for child classes to override this function without having to rewrite the loop of iterating through all of the trades. For the base class, for both update common values and apply trailing stop, I'm simply returning because I don't have any implementation for these. I'm expecting them to be overridden in the inheriting classes. Now let's look at the functions that I've written for update trailing stop. This is the general purpose update trailing stop that will iterate through all trades. It's calling the update common values, which you'll remember is going to be overridden by the child class if needed. And then I'm simply doing the traditional loop through trades, getting the orders total, iterating through those in a for loop, selecting the trade by position. I'm checking to see that the symbol matches the M symbol, which is stored in the common base class. The magic number matches the magic number that's been passed in when we created the instance of this class, and then calling the apply trailing stop method, which I'm expecting to be implemented by the child class. For a specific ticket, I want to first check if the currently selected ticket is not equal to the ticket number passed in. Then I'm going to do an order select, and if that fails, so if I don't get a success from that, then I'm just going to return. You might want to do some more error handling, but I'm simply returning here. The other thing I want to do is check that the ticket number passed in matches the symbol, matches the magic number, and that it is not closed. So I'm just checking to see that the order close time is equal to 0 before applying any trailing stop. And then update common values. Although this is for a single ticket, I'm just doing that update because I don't know that those values are correct for a single ticket. And then the apply trailing stop. And both of these can be overridden or expected to be overridden in the child class. And that's everything for the trailing stop base. So let's look now at the specific implementation of the trailing stop class for this EA. So here I have a skeleton for the trailing stop class, which I've called triple cross trailing stop. It's going to be inheriting from the trailing stop base. So I have the include file, and because I'm keeping it in the same folder as the trailing stop base, I've used the relative addressing here with the quotation marks rather than the angle brackets. Class C triple cross trailing stop, public inheritance from C trailing stop base. Remember that I've added that trailing stops will be based on ATRs with minimum values. So first thing I want to do is store the variables, or create the variables where I'm going to be storing that information. So these just match the inputs that we're going to get from the EA. There's an ATR period, stop loss multiplier, take profit multiplier, and then the stop loss and take profit minimums. Here are the constructors for the trailing stop class. I have two constructors. The first accepts the magic number that we need, which is going to be passed into the base class. Then arguments for the ATR period, stop loss, take profit multipliers, minimum pips for take profit and stop loss. Calls the C trailing stop base constructor, passing in that magic number, and then calls the init method inside this class, passing the ATR multiplier and stop loss and take profit values. The other constructor only adds the symbol and time frame, which I do by habit because that will then call the alternate constructor for the base, passing in the symbol and time frame as well as the magic number. And if you remember, the base will then call the common base and pass that symbol and time frame. Other than that, the init call is the same for both of these constructors. The init method then, as you would expect, matches the call from the constructors. And then let's go down to the implementation of the init method. So here's the init method. Same arguments as you would expect. The usual check to see if the base class initialization has failed. Then I'm doing some validation on the values being passed in. The ATR period must be greater than or equal to 0. Here I'm using the set init result that you remember is from the common base, passing a default error message, and init parameters incorrect, and then doing the same thing for the stop loss multiplier and take profit multiplier. They must be greater than 0, error message and incorrect parameters. And then I'm checking the minimum pips. I'm allowing minimum pips to be 0 because this is a way that you can simply say to ignore them, but negative values will cause a problem, so I'm just checking for those being less than 0 and failing. And then all I'm doing is storing these values, storing the ATR period and the stop loss multiplier and the take profit multiplier directly. But for the stop loss minimum and take profit minimum, they were passed in as a pip value from the inputs. So I'm converting those using the pips to price function that we moved into common functions here. And that's one of the reasons that I moved that into this common functions. Remember, the common functions are now available because they're included in the common base. And so everything that inherits ultimately from common base by including that common base file will have access to these pips to price functions. The base class already includes the update trailing stop methods that I need. I'm going to override the update common values and the apply trailing stop in my triple cross trailing stop class. So first thing to do is to define functions. I'm making these public because they'll be called by the application, and then I need to implement those. So first, the update common values. Because I'm using an ATR value, this is exactly the reason I would want to do this once only, because it's not going to change for each trade. So by calculating this once in the update common values, I'm able to store the ATR value, the stop loss value, and the take profit value calculated once. So ATR, a simple IATR call. For the stop loss value then, I'm multiplying the ATR value by the stop loss multiplier, and then I'm taking the maximum of that or the stop loss minimum, and I'm doing the same for the take profit value. And of course, because I'm using 3 member variables, I'll just need to create the member variables for those. And I'll put them in the protected section here. Okay. Now let's look at apply trailing stop, because this is where all the real work happens. I'm just setting a result value that I can use, as you can see here in the order modify functions. I like to capture those values even if I'm not using them, because I don't like to have compiler warnings. A compiler warning could be an indication of a real fault, so if I can eliminate those, then when I do get a warning from the compiler, I know that there's a problem that I need to investigate. So I could have made this a very complex single step process, but instead I'm making it simpler inside the code here. I'm applying the trailing stop in this block of code, and then in this block of code I'm going to apply the trailing take profit. So first thing to do is calculate the stop loss price for the individual trade, and I'm using normalized double because by doing a multiple of the ATR I may get a value that's an invalid pricing value. So the normalized value, the normalized double function passing in m digits, which again comes from the common base, will normalize this to a price that I can use. And now I have a function here called sub, which I've referred to in other videos. This is a standard function that I use that will calculate effectively close price minus stop loss value in the direction of that order. So if this is a buy trade, then it will calculate close price minus stop loss value, and if it's a sell trade, it will calculate close price plus stop loss value. And I'm going to put that function into the common functions now. Going to common functions, I'll just paste these in. Okay, there are 4 functions: open price, close price, add, and subtract that I'm creating here. They each have 2 implementations, one that takes a trade type as an integer, because trade types are often integers in Metatrader, and all those implementations do is to then call the other implementation by casting the trade type to an enum order type. So the open price function simply determines if the order type is a buy, then it will return the ask price, and if not, then it will return the bid price. So it's giving you the current market opening price for a buy type trade. And I'm using this trade type %2 because that will handle buy, buy stop, and buy limit. Then the close price does the opposite. If the order type is a buy, then it returns the bid price, and if not, then it returns the ask price. And again, I'm using the %2 modulus operator here to determine whether it's a buy, buy stop, or buy limit. The next 2 functions, add, same implementation, int trade type being cast to an enum order type. So add, again, if the order type is buy, then I'm adding V1 to V2, and if the order type is not a buy, then I'm subtracting V2 from V1. So this can be read in the code as the add function returns V1 plus V2 in the direction of the trade type. And subtract, the same thing in reverse, and this can be read as V1 minus V2 in the direction of the trade type. And as I've already said, if this is a sell order, then this will effectively be V1 plus V2, and if it's a buy order, it will be V1 minus V2. So I use these functions simply to avoid having to put this kind of logic throughout my code. It makes it a little bit more readable once you get used to the idea of seeing these functions, and it means they're more generic because the trade type can be passed into anything. Let's go back to the trailing stop class. So I'm using the sub function here. I'm calculating close price minus stop loss value to give me the stop loss price. And then I'm using a macro here, GT, and let's go and create those also in the common functions. Paste these in. I use these for the same reason as I have the open price, close price, add, and sub, because I frequently want to know if one price is greater than or better than another or less than, and we typically have to convert between buy and sell types. Now these have to be on a single line because I'm using define statements, so I'm just going to have to scroll across to show you these. I've defined 4: greater than or equal, less than or equal. And I've defined these as macros because effectively this code will be substituted rather than a call to a function when at compile time, and that just makes the code run a little faster. I could just as easily have created GT, GE, LT, and LE functions, but that's yet another function call that has to be executed inside the code. And all this is saying, if the trade type %2, the same modulus operator, is an order type buy and V1 is greater than V2, or if it's an order type sell, scrolling across here, oops, sorry, went too far, and V1 is less than V2. So I'm doing the same piece of code here that I would embed within my applications. I've just defined it in a macro. So by using a function of _GT, passing 2 values and a trade type, then it simplifies my code. Also, because this is a macro, I can't define this as an enum. In fact, I can't define any of these as a particular type. So I could put anything into that function. It will fail at compile time because if I put a string in here, for example, then it will attempt to use a string in this comparison and fail. But I can't define those types in the macro definition. So let's go back to the trailing stop function. So I'm saying here, if the stop loss price is greater than the order stop loss, so I only want to move the stop loss prices forward, given the order type, or if the current order stop loss is 0, so if no stop loss has been set, then I'm just doing a standard order modify call, passing in the order ticket, the open price, the calculated stop price, the current order take profit, and the current order expiration, which is not applicable to my current EA because I don't have buy stop or buy limit orders, but as a class I need to be able to deal with that, just in case I'm using it from another EA that does place stop and limit orders. Take profit is a little bit different, or the trailing take profit is a little bit different. I'm using similar functions because this is a take profit price I want to add, but I'm adding from the order open price. So here with the stop loss, I was calculating from the current market close price. My take profit, I only want to adjust if the ATR changes. So as the ATR gets smaller, I want to bring the take profit price back towards the order open price. And of course, if the ATR gets bigger, I want to move that further away. So the take profit price is flexible. If I implemented this in the same way as the stop loss price, then I would always be moving the take profit price further away from the current market price, which makes no sense because you would never reach it. So other than that, the values are the same. Order open price, I'm adding to that the take profit value for the given order type using normalized double, and then the functions are similar, but I don't need to use the greater than or less than functions because I'm simply saying I'm going to adjust the take profit price if it is different to the current order take profit. And I've also added order take profit is equal to 0 just in case, but realistically this one condition would take care of everything. And then again, it's just an order modify, but in this case I'm passing the take profit price and using the current order's stop loss price, and then return. That's everything for the trailing stop class. Back to the triple cross v3 EA now, because I have all of the classes in place. First thing I need to change, because I've moved the triple cross filter into the subfolder for experts, I'm just going to update this. And I've now added a trailing stop class, so easy way is to just duplicate that. We've already covered the inputs. I no longer need this take profit and stop loss value because those are all held inside the trailing stop class. I do need to create an instance of the trailing stop class, so I'll just create that variable there. I've added the new arguments, so I'm just going to replace this creation of the filter where I'm passing the applied price values. Then I want to create an instance of the trailing stop class. That looks very similar to the filter class. Creating a new instance, passing the usual values, and I'm doing the same check to see if that failed in the initialization. Previously I had this call to validate inputs where I checked to see that the values being used for things like trailing stop and take profit were valid, but all of that's handled now inside classes. So I'm just going to remove validate inputs. And I'm just going to then return init succeeded. If I go down to the dinit, I now have a second object to remove. So I'll remove the trailing stop there. In the onTick function, most of this is the same. All I want to do now is add the trailing stop, and that's as simple as doing trailing stop.update trailing stop. Remove that validate inputs function because we no longer need that. The isNewBar function doesn't change. I am going to make a change to the open trade function. I don't need to calculate the take profit or the stop loss price. So I can remove those because I'm going to use 0 for both the stop loss and take profit price now. And then to apply those to that ticket once it's been created, I'm going to call the update trailing stop method that we created for a single ticket, because all the functions to calculate the size of that trailing stop or the size of that stop loss and that take profit are embedded inside the trailing stop class. So rather than duplicate them here, I'll just make one call to that function. There's no change to the close trade function. So I should now be able to compile this, and that worked. I do need to make a change to triple cross v2. I tried to maintain compatibility, but because I've added these pip size and pips to price functions into common functions, triple cross v2 will need to have these removed, otherwise I'll get a compiler error that I've included them twice. So what I'll do is add this include statement from v3, and I do that although they're going to be included simply by calling any of these classes or including these classes. I just like to make sure that everything that this application needs is included directly, because I never know if in future this triple cross filter class might change and no longer include those common functions. So do that, remove these. I've already updated this include statement to have the new path name to the triple cross filter. And let's just see if this compiles, and it does. So this is still using the old constructor, and I've maintained compatibility then inside that class. Covered a number of things today, so I just want to go over them all again quickly. Created a common functions which I will use again and again, because I'll continue to add functions to this that I'm going to use in many other places. But at the moment all we have is this conversion of pips to price, which we used last time, and I've added my standard comparison functions: greater than, less than, open price, close price, add and subtract. The common base class hasn't changed, other than to include those common functions here, and by including that, every class that inherits from common base by using the common base inclusion will get that. Filter base, there was no change. The triple cross filter I've updated because I'm now including an allowed applied price, but I've maintained compatibility by having two sets of constructors, one that uses the default applied price and one that uses the new applied price. I've created a trailing stop base class which can be used for any trailing stop method that you might want to apply, so just by inheriting from the trailing stop base class. And it has the standard functions: update the trailing stop and update it for a single ticket. In my triple cross trailing stop then, I not only updated the trailing stop, I also updated a trailing take profit. So this shows that just because the function is called update apply trailing stop, it doesn't have to be just the trailing stop. And because this is inheriting from the trailing stop base class, all I have to do is write these functions for apply trailing stop and to calculate any common values. If we go back to the triple cross v3, the expert advisor now, once we get past the inputs, the init is really just creating these two classes, the filter class and the trailing stop class. It has a new bar function, but now there's very little code inside the expert advisor. I'm just checking for the signals from the filter and I'm applying the trailing stop. And then the use new bar, open trade. So you can see we're gradually reducing the size of the EA. And if I wanted to take this a few steps further, we could get down to the point where this EA is a standard template and has no new code required for each EA. The thing I want to point out here, I've used this filter to generate both the entry and the exit signals, but there's no reason why you couldn't have a different filter for the entry and exit signals, and you would just do something like so you could just create another filter class for the exit filter, and you can combine these then into your EA quite easily. And you can do the same thing with the trailing stop filter. So where I have the single trailing stop that does the trailing stop and the trailing take profit, you could create two of these classes and call them separately. And this is just the kind of flexibility you get by using object-oriented design and classes to implement these. And since they all inherit from the same base class, you could even have these such that the user can select them from an input statement at runtime, and then you can simply create classes of the type selected by the user. And that will wrap up everything that we're looking at for, just make sure that still compiles. That wraps up everything for creating this EA. We started with a base triple cross EA that used no object-oriented concepts at all, and only took a fixed entry and or fixed take profit and stop loss. We went on to the version 2 triple cross that implemented the filter function, which gave us entry and exit signals. And now in the version 3 we have entry and exit signals plus a trailing stop based on the ATR. I'm hoping that this has been useful to you. There are some more planned in this series. We're looking at the telemetry that I put off. I was planning to do several weeks ago, but I've put off the telemetry while we created these expert advisors. So now that I have these, I'll be able to add telemetry into this expert advisor next time. And then a couple of minor updates, and that should bring to a close this particular series on object-oriented development. I hope you found this useful. This won't be all we're creating. There are other videos on other topics coming. So please, if you want to see those, remember to click the subscribe button and the bell icon to be notified when these videos are released. If you found this useful, click the like button. It helps us a lot. And again, thank you for watching.